So in our first example, it tells us to find the effective value, that is the RMS value of the waveform below. So what are the steps? You need to find a cycle and also note down our period, and after that we can find the area under the cycle. So what's the cycle? Let's see. The cycle is from 0 up to 6 before the waveform will repeat itself again. So our cycle is from 0 to 6. So then the period will be from here up until here, right? So your period here is 6, this time 6 seconds. So then the next step for us is to find the area, because RMS is this 1 over t, that is the period of the cycle, and from 0 to t we square the function like this, which is the same as area over the period. So let's take a look at something. In the first place, we should know that the period from 4 to 6, or the area over here, will be 0 because it lies on the x-axis. If you watched my video on how to find the RMS values of various waveforms, you see that whenever a cycle lies on the x-axis like this, the area is 0. So now our headache, or the focus, is to find the area under this triangle, that is from 0 to 4. But then you can see that I can divide this into 2, and I'll have one sawtooth here, let's say this, and another sawtooth here. So then they are the same. So if I am able to find the area for just one and I multiply it by 2, I can get the area from 0 to 4. So I'll try and find the area for just one side. After that, I'll multiply it by 2 and I'll get the area for the bigger triangle, that is from 0 to 4. So then how do we do that? We are saying that this is a straight line, so that we can say that from y is equal to mx plus c, we can find the function. So in this case, our y is vt and m is the gradient. In this case, x is t and c is where the line, this line, cuts the y-axis, and we can see from here that it cuts the y-axis at 0. So your c is 0. So then let's find the gradient, that is change in y by change in x. So let's use coordinates. Let's say the coordinate here is 2, 3, because we have 2 here on the x-axis, and the peak value, that is on the y, to be 3, and we have the coordinates here to be 0, 0. So if this is your x2, this is your y2, and this is your x1, this is your y1, we can say that the gradient will be 3 minus 0 all over 2 minus 0. So your gradient here will be 3 on 2. So then our function vt will be equal to 3 on 2 times t. So this is the function of triangle 1, or the sawtooth, the first one. So if you find the area of this one, you multiply it by 2, because we have 2 sawtooth, we have 1 here and 1 here. So if you multiply it by 2, then we can get the area under this bigger triangle from 0 to 4. So let's start. VRMS. So I'll take out the square root and do it. After that, I'll bring back the square root. So let's see, it will be 1 out of t from the equation, and this t is the period of the cycle, and the cycle ranges from 0 to 6. Don't miss that. The cycle starts from 0 and ends at 6. So it will be 1 over 6. Then we will integrate from 0 to t. So now we are dealing with just this first triangle, or this first half. So it is from 0 to 2, and then we will bring our function, that is 3 on 2t all squared dt. So then from here we can say that 1 on 6, integrating from 0 to 2, we can say that we will have 9 on 4 t squared dt. But since 9 on 4 is a constant, we can bring it out. So it will be like this: 9 on 4, integrating from 0 to 2, we have here to be t squared dt. So VRMS will be equal to 1 on 6 multiplying 9 on 4. But when we integrate t squared, we will have t cubed on 3 like this, and the limit from 0 to 2 dt. So we have 1 on 6 over here, 9 on 4 times 2 is the power 3 all on 3. So that is 1 on 6. So multiplying 9 on 4 times 8 on 3 like that. So I'll have 1 on 6 times 6 over here. So this is 6 on 6. That is 1. So this one is just the area for the first sawtooth, but we have 2, right? So if you want the full one, it is 1 times 2. Your answer will be 2. So your final value, that is the VRMS, should be equal to the root of this. And you have 1.414 volts. If you don't want it this way, or if this is a very long method for you, I said in my other videos that if you have a sawtooth and you want to find the RMS value, you need the area, right? And you divide by the period of the cycle, and then you take the square root. And I said you could use Vm squared all over 3 times the period, and that will give you the area. I said that. So Vm squared over here was the amplitude. So looking at this, the amplitude over here is 3. So this one will be 3 squared on 3 times the period, that is 2. And this should give us 9 on 3 times 2, which is 18 on 3. But this is just the area for one. So if I want both, I should multiply this by 2 and divide by the period of the cycle, that is 6, and take the square roots, and this should still give me 1.414 volts. So in example 2, we have to find the RMS value of the waveform below. So as usual, we will find our cycle, and we will note down our period, and after that we find the area under the cycle. Then we will divide by the period of the cycle, and then we take the square root of that, and then that will give us the RMS value of the waveform below. So let's look. What is the cycle? The cycle starts from 0, moves like this, goes up, comes down like this, ends here, and the cycle repeats itself. So it means the cycle is from 0 to 10. So then the period will be 10 seconds. And the next step is to find the area of the cycle. So let's see. In the cycle, I can see that we have a sawtooth here, that is 1, a square wave here, that is 2, and another sawtooth here, that is 3. So that means we have 2 sawtooth, that is this one and this one over here. So then if I know the area for 1 and I multiply it by 2, I should get the area for this and this, and then I can also find the area for this square wave and add them. After that, I will divide by the period of the cycle, that is 10, take the square root, and that gives me the RMS value. So let's start. I will begin by finding the area for this sawtooth, this one, this first one, because we know that the area from 0 to 2, that is on this line, is 0. We explained that in the other videos, that area on this line, on this x-axis, is always 0. So then let's find the area of this sawtooth. Right, so we know that this is also a straight line. This is a straight line, so then we can use our y is equal to mx plus c to do it. So y in this case is vt because the function is a voltage source here, as you can see. M is our gradient. X in this case is t because it is with respect to time, as you can see over here. And c over here is the intercept, or where this line cuts the y-axis. So let's see. This line is going to cut the y-axis at -10. Okay, so then we can find the gradient, that is m, changing y over changing x. But we should find the coordinates before of the line. So let's say here is 2 and 0. So the coordinates here will be 4 and 10. So let's say if this is x2 and this is y2, this is x1 and this is y1, I can say that my m will be 10 minus 0 all over 4 minus 2, which is 10 out of 2, which is 5. So then the function of the sawtooth here, I mean this one, is going to be 5t minus 10. That is the function for the sawtooth. So if we know that this is the function for one sawtooth, we can find, using integration, the area and multiply by 2 because we have 2 sawtooth, that is this and this. So that we will get the area for the 2 sawtooth over here, and then we can find the function under the rectangle here. From my other videos, you know that function under a square or a rectangle is the same as the amplitude. It's the same as what? The amplitude. And in this case, I can say that v2t, that is the function under the rectangle here, is 10. So then from here we can find the area, but then before that we know that RMS value to find it is 1 on t, 0 to the period, you square your function like this, dt, which is also the same as area, square root of the area by the period of the cycle. So then let's find the area under the cycle. So the area under the cycle, so for the sawtooth, we will integrate from 0 to 2, because from 2 to 4 the distance is 2, so I can make it 0 to 2. And then the function under the sawtooth was 5t minus 10. But in finding VRMS, we square the function dt. plus the area of the rectangle, that is from 0 to 4, because this is from 4 to 8 and the distance is 4. So I can say that integrating from 0 to 4 is the same as integrating from 4 to 8. So then the function here is 10 squared dt. So the area, expanding this from 0 to 2, you have 25 t squared minus 100t plus 100 all times dt plus, integrating from 0 to 4, here will be 100 dt. So then we should take note that the one in bracket is the area for just one sawtooth. So then we can multiply it by 2 to get the area for the double sawtooth over here, right? Area will be equal to, you can see that the 25 is a constant, so I can bring it out and integrate from 0 to 2. We have t squared over here. I can bring the 100 out, integrate from 0 to 2. We have just t here, all the t, right? All the t, and I'll have plus 100 here, integrated from 0 to 2, dt, and the last one will be from 0 to 4 for dt over here, and I'll bring the 100 out, this 100. So then the area will be equal to 25. So then this is going to give us 3 cubed and 3 from 0 to 2 minus 100. Integrating t will be t squared on 2. That is from 0 to 2 plus 100. Integrating the t will give us t from 0 to 2 plus 100. Integrating the t again here will be from, will give us t, that is from 0 to 2, that's the limit. So then we can say that area is equal to, this was the one in bracket, if you could remember. You shouldn't forget, because this is the area for just one sawtooth, but we have 2. So then by substitution, you can say that 25 is going to multiply 2 cubed on 3 like this over here, minus 100 2 squared on 2 plus 100 times 2 plus 100 times 4 here. But this is the one in bracket. In other words, that is the area for just the first sawtooth, but we have 2. So we can multiply this, the one in bracket, by 2, so that we will get the area of the 2 sawtooth. So it will be like this, 3 minus 100 2 squared 2 plus 100 times 2 like this, plus 100 times 4. So when you punch this on your calculator, the area for everything should be 1600 on 3. But we are saying that the RMS value is the same as area all over the period of the cycle. So now we can say that area is 1600 or 1600 divided by 3 divided by the period, which is in this case 10. So your RMS value, in this case the RMS voltage, should give you 7.3 volts. Alright, so what if for the same question you have this in your, let me say, your MCQs, alright? You don't need to work out those long steps, okay? So in my, earlier videos, I said that if you have a sawtooth and you want to find the area, so let's say area of a sawtooth, right? I said that it is Vm squared on 3 times the period of the sawtooth. And if you wanted the area of a square or a rectangle, okay, or a rectangle, the formula is just Vm squared times the period. It should give you the answer straight away without doing any integration. Right, so let's see. For the area under the sawtooth, we have two sawtooth, right? We have this one and we have this one. So the Vm here stands for the magnitude or the amplitude or the peak value, okay? So let's look at this. The peak value under the sawtooth in this diagram is what? 10. That is 10 squared and 3 times the period of the sawtooth. Right, here was 2. So the difference here from 2 to 4 is 2. So I can multiply this by 2. But let's take note that the sawtooth in this question or in this cycle is 2. We have 1 here and we have 1 here. So you should multiply the whole of this by 2. And let's let's try and find the area under the square or the rectangle. We have our Vm, that is the amplitude or the peak, which is 10. From the formula, should be squared times the period. In this case, from 4 to 8, which is the same as 4, right? So when we add this and this, we should get the area under the full cycle, right? So it will be 2. 10 squared is 100, all divided by 3 times 2, and this should give me 2 multiplying 200 all on 3. And for the square, I should have 100 times 4, which is 400. So the area under the cycle should be 2 or 400 plus 2 times 200 all on 3, which is the same as 400 plus 400 on 3, and this should also give us 1600 on 3. So this is the area for the full cycle, right? And we know that RMS value, and in this case the RMS voltage, is always the same as area all over T. The T here is the period of the full cycle. So we have our area ready, which is 1600 divided by 3, and we also have to divide the whole thing by the period of the cycle, that is 10, and this should give me 7.3 volts. So if you use integration or this very simple method, you should get the same thing. You should only use this when maybe you have multiple choice questions. You don't have to waste time by doing integration and all that. You can just go straight to the point, and this should give you the same answer as using integration. Thank you. So this will be some trial questions for you guys to try your hands on. So the question 3 says you should find the average value and the RMS value for the waveform below. So I have the answers over here. So when you try them and you get them, then hooray, then it means you've understood. And if you don't get it, that means you need you need a lot of work. You have to sit down, or you can contact me, and maybe you can see me privately, then we talk about that. And the question 4 also says you should find the RMS value of the waveform below. I also have the answer here, but I never spoke about average value. Average value is the simplest. So let's say V average. If you want to find V average, it is just 1 over the period integrating from 0 to t, just your function, the t. There will be no squaring of the function. There will be no let me say square root. So in other words, V average is the same as finding the area and dividing by the period without no square root or squaring of the function or any other thing.